This week in the classroom we're going to be learning to use addition and subtraction to solve equations. And I know that sounds like a mouthful, but it's probably something most of you have been doing since you were about in second grade. Let me give you an example. Suppose the problem said 3 plus a equals 5. Well, what we're trying to do is find out what a equals. And for most people they would say 5 minus 3 equals 2, and that's what a equals is 2. But we're going to be working on a thing called an inverse operation. An inverse operation has the effect of canceling. Let me give you an example. If we want to get a to be all by itself on this side of the equal sign and the answer to be on the other side, then we have to get rid of this 3. We have to cancel this 3. So we'll put a negative 3 with it. A 3 plus negative 3 equals 0. It's gone. What we do on one side of the equal sign, we have to do the other side. So we bring the negative 3 over here. Now, we have to, if we do our calculations here, we say 3 minus 3 is 0, and so a is all by itself, and 5 minus 3 equals 2, which is the answer. Now, if we wanted to check that, what we would do is we would substitute the 2 in place of the a, and we would say 3 plus 2 equals 5. Now, if that's a true statement, then we have a correct answer. And that's pretty much all there is to it. Another example of the use of an inverse operation would be with subtraction. Let's say that you had a minus 4 equals 5. Well, in this case, more than likely what you would do would be say 5 plus 4 equals 9. And 9 minus 4 does equal 5, and that would be true. We're going to teach the children, however, to use that inverse operation and do this. Put a positive 4 with the negative 4, because that would have the effect of undoing the negative 4. It would equal 0. What we've done on this side of the equal sign, we're going to do the exact same thing on this side. We're going to bring the positive 4 over there. Then when we do the calculation, we would say negative 4 and positive 4 is 0, leaving a all by itself on this side of the equal sign. We would then bring it over here and we'd say 5 plus 4 is 9. And again, if the objective was to find out what a equaled, a is telling us that it equals 9. Before we go on, I have to show you a thing called combining like terms. Basically what this means is if you have a coefficient and a variable, the 3 is called a coefficient. The a is called a variable. Coefficient and variable that is the same, if they have the same variable, then they're known as like terms. This could be combined together and we would equal 5a. That's called combining like terms. We can add the 3 and the 2 together only because they have an a variable with them. You can do the same thing when you solve equations like this. Perhaps you had a problem that says 3 plus a plus 2 equals 7. Now, before we can get to that inverse operation that we spoke of a minute ago, you have to combine like terms first. So, we have a 3 and we have a 2 that do not have a variable with them. They are like terms. They're not a like term with a because a has its variable, it's 1a, and there's no variable on these. So we put these together and we get 5 plus a equals 7. Now we're ready to do the inverse operation. We have a 5 with the a on this side of an equal sign. We take a negative 5 with it to undo it, and then we take the negative 5 over to this side of the equal sign. When we do our calculation, positive 5, negative 5 cancels itself. This winds up a equals 2. And if the objective, again, was to find out what a equals in this equation, we would find out that a equals 2. If we take that 2 and put it back in, we would have 3 plus 2 is 5 plus 2 equals 7. We have a true statement, which is a way of also proving this in the end. That's about all we have for today. I'd like to thank you for your time, and I hope this helped you a little bit.